Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. It's good to see all of you again. So as you see on the screen here now, we are now in lecture 3 of 3, the last final part for topic 6, polynomials, partial fractions. Okay, so students should be able to construct partial fractions, decomposition. Okay, so we got a linear factors, a repeated linear factors, and a quadratic that cannot be factorized. Okay, so and also here, change the rational polynomial to proper fraction. Degree of numerator is same or more than denominator of the partial fractions. So partial fractions. A single proper algebraic fraction can be expressed as sum or difference of two more than proper fractions. Example here. Okay, so are known as partial fractions of this one here. Okay, I'm not going to spend much time on this one here. The proper fraction, as you see here, the degree of x from the numerator is less than the degree of x from denominator. And also here, the degree of x from numerator is less than from the degree of x from denominator. An improper fraction, the degree of the numerator is greater than or at least equal to the degree of the denominator. So the degree of numerator x4 is greater than here denominator for x, which is 2, or this one here, or at least equal. Okay, so now partial fractions with case number 1 and also case number 2, improper fraction. So for case number 2, when it comes to the question of improper fraction, we need to make some adjustment by using long division. So then the fraction will become the proper one. Okay, and the denominators are in the form of linear factors, repeated linear factors, and quadratic. They cannot be factorized. So three things here is the one that we'll discuss for the whole of this topic, a subtopic. Okay, then example. Okay, denominators in the form of linear factors. So you can see here now the denominators in the form of linear factors, x minus 1 and also x plus 2. Okay, so we separate this and put the numerator with a where we call the alphabet of A and also B. Okay, linear factors. And also here, the denominators in the form of a repeated linear factors. Which one that represent this? Repeated linear factors, x squared or 2x minus 1? Yes, x squared. X squared represent a repeated linear factors. As you see here now, first we write down as an x and then x squared, and you can see here it's not in the form of bx plus c. Even though this is x squared, we define as a quadratic, but it's not a quadratic. We define it as one as an x and also x that repeated twice, and the alphabet of b is not in the term of bx plus c. Okay, and this another linear, then we come up with a c. Repeated linear factor. And the quadratic that cannot be factorized, for example here. Okay, so x squared plus x plus 1. For example, for x squared minus 5x plus 6, that we can transform this into two linear factor, which is x minus 3 and x minus 2. So these two we define as a two linear factor. But at this one here, x squared plus x plus 1, we cannot factorize something like this one here now, so it retains as an x squared plus x plus 1. And then look at this one here now, it come up in the form of bx plus c. The quadratic factors that cannot be factorized. Okay, so example 1. Okay, so for this one here now, 2x plus 3 divided by x minus 1 and x plus 2. Okay, so write this one as an a divided by x minus 1 plus with b divided by x plus 2. Okay, the reason that I give a space between this fraction and this fraction, we are going to simplify this, and we call equalize the denominator of this and this back to the origin here of x minus 1 and x plus 2. So slowly with me here, with me, okay, we are going to equalize the denominator of this a divided by x minus 1 and compare with this. It is x minus 1 multiplied with x plus 2. So we are going to multiply this with x plus 2 and also x plus 2. And what about this one here now? B divided by x plus 2. And we're going to compare with the denominator from the questions here. And we need to multiply with x minus 1 and x minus 1. Okay, now both of this fraction now has recall the equal denominator, okay, with the questions of x minus 1 and x plus 2. So now we may compare the numerator 2x plus 3 equal to, okay, a times x plus 2, ax plus 2a, and plus with b times x equal to bx, b times negative 1 minus b. And the coefficient of x, which is a and b. So a and b multiplied with an x plus with 2a minus b. Okay, so from here we're going to compare the coefficient of x, a plus b, with the coefficient of x, which is 2 here. So a plus b equal to 2, and the coefficient of, okay, the constant of 2a minus b with 3. 2a minus b equal to 3. Equation 2. Okay, so two equations with two variables. I think that you know what to do then here next. Let's say equation 1. Equation 1 plus with equation 2. Okay, a plus b equal to 2. 2a minus b equal to 3. Okay, plus here. So b plus negative b or b minus b equal to 0. A plus 2a equal to 3a. And 2 plus 3 equal to 5. So then a equal to 5 divided by 3. Okay, and then substitute a 5 over 3 into equation 2, 1 or equation to either one. Okay, so a plus, okay, no, a is 5 over 3, 5 over 3 plus with b equal to 2, then b equal to 1 over 3. So class, guys and girls, now from here we come up with a conclusion that how do I use that here now? Okay, sorry if I quite recall. I'm gonna use this one here now. 2x plus 3 divided by x minus 1 and x plus 2 equal to a is 5 over 3, so then it is 5 divided by 3 x minus 1, and then b is 1 over 3 plus with b here. Okay, we take this one only plus with b, which is 1 over 3 x plus 2. This is the answer then here. Okay, with the value of the a is 5 over 3 and b is 1 over 3, and we refer to this one here now, then this is the final answer. Okay, now the second example, repeated linear factors. Okay, so express this as a partial fraction. Then the first one here now, we come up with 3x plus 1 divided by x squared, and then multiply with x plus 1. Okay, so then first we come up with an x plus with x squared plus with x plus 1. Okay, now this is a repeated linear factor, the case of repeated linear factor. So we can just come up with this, we'll write this one above here with the capital letters of A, capital letters of B. I mentioned earlier, even though this looks like a quadratic x squared, but it's not a quadratic, it is defined as a repeated linear factor of x, so the numerator come up with a B and also C. Okay, now x, we are going to compare with the denominator of x squared multiplied with x plus 1. So now, okay, so it needs, we have x and we need another x, so we are going to multiply with x and also x, and it needs also another of x plus 1, so then x plus 1 and also x plus 1 here. Okay, then next, for b divided by x squared, it already have x squared, so then we need another of x plus 1 divided by x plus 1. And then we will compare this denominator of this x plus 1, it already have x plus 1, it just need another of x squared. So then multiply with x squared and also x squared. Now let's compare the denominator of each of these. X times x, x squared, multiply with x plus 1. x squared times x plus 1. X squared multiplied with x plus 1 equal to x squared multiplied with x plus 1. And x plus 1 multiplied with x squared. Yeah. It gives you x squared times x plus 1. So now, we are going to compare the numerator, which is 3x plus 1 equal to, okay, a times x plus 1, it gives you ax squared plus with ax. Then b times x equal to bx plus with b times 1 equal to b. And c x squared. Okay, then we are going to compare with this one here. Okay, so ax squared with cx squared. A plus c x squared plus with, okay, now the coefficient of x and also x, a plus b times x and plus with a constant of b. Okay, now let's compare the constant with constant. So clearly that b equal to 1. When b equal to 1, so let's now compare this a plus b, the coefficient of x, with 3. So then a plus b equal to 1 equal to 3. Then a equal to 3 minus 1 equal to 2. Okay. And then a equal to 2, we're going to find out what's the value of c here. Do you find any term of x cubed here? So we assume that this is 0x cubed. So a plus c, a equal to 2 plus c equal to 0, then c equal to negative 2. Okay, now let's rewrite all this again. 3x plus 1 divided by x squared, x plus 1 equal to, okay, this one here, a over x, where a equal to 2 divided by x, plus with b, okay, the blue one here, the blue ink, b equal to 1, so 1 over x squared. And this one here now, c equal to negative 2 minus 2 divided by x plus 1. Okay. Good. Okay, next. And now, cases where we call the denominators in the form of quadratics that cannot be factorized. Example 3, so form this as a partial fractions. And for this one here now, 4x divided by x plus 1 and 3 plus x squared. Okay, this is the things here now. A quadratic that cannot be factorized. Okay, so then a divided by x plus 1 plus with, okay, divide by 3 plus x squared. So in this case, we come out with the numerator of bx plus c. Okay, so let's compare this with this here. And again, I'm going to use the different ink just to make a difference from them. Okay, now, okay, it has x plus 1 here. it needs another of 3 plus x squared. So then multiply with 3 plus x squared, and also here 3 plus x squared. And what about this one here now? Bx plus c. It has 3 plus x squared. 3 plus x squared. It needs another of x plus 1 here. So multiply with x plus 1 and x plus 1. Okay. So now all these two look at we call the denominators, one here and another one here. Both are equal with the questions. So we may now just compare the numerator of 4x equal to, okay, now a times 3 equal to 3a. A times x squared equal to ax squared. Bx times x, bx squared. B times 1, bx times 1 equal to bx. C times x equal to cx. And c times 1 equal to c. Okay, so now we are going to arrange, we call this one here, okay, the coefficient of x squared and also x squared. So we put them all together, a plus b of x squared, and then coefficient of x and also x, which is b plus c multiplied with an x, and also 3a, the constant, with c, plus with 3a plus c. And let's compare with this one here, 4x, meaning the coefficient of x squared, there is no x squared here, so a plus b equal to 0. The coefficient of x with an x, so b plus c equal to 4, and also 3a plus c. Do you find any constant here? No. Okay, so 3a plus c equal to 0. Okay, now guys, girls, look at this one. The first equation, a plus b, b plus c, and 3a plus c. I'm going to make some adjustment here by making that a equal to negative b, and substitute this. Okay, this is the equation 1, equation 2, and equation 3. Okay, so equation 1 substitute into an equation 3. Equation 1 substitute into equation 3 here means that look at a here, and a equal to negative b, so come out with 3 negative b or negative 3b plus c equal to 0. And now let's compare this negative 3b plus c equal to 0 with b plus c equal to 4. Let's say this is equation 3. So then equation 2 minus 3. So b plus c equal 4, negative 3b plus c equal to 0, minus, so c minus c equal to 0, negative become positive, so b plus 3b equal to 4b equal to 4. 4 minus 0 equal to 4. So then b equal to 1. Okay, so then from b equal to 1, let's use into an equation 1 where b equal to 1 and a equal to negative b. So then a equal to negative 1. And then 3a plus c equal to 0. Let's substitute a equal to negative 1 into this equation. 3a negative 1 plus c equal to 0. This become negative 3. Then c equal to 3. Okay. And again, we are going to compare this equation, we call the equation itself, with this one here and this. So this equation, this expression equal to a equal to negative 1 divided by x plus 1. And then bx plus c, b equal to 1 and c equal to 3, plus with b equal to 1 times x equal to x plus 3 divided by 3 plus x squared. So this is the answer that we want. Okay. Partial fraction for an improper fraction. Improper fraction, for example here, x multiplied with an x, it gives you an x squared. And the numerator here, x with a degree of 3. So this is we call simple example of an improper fraction, and we are going to use the long division to form a proper fraction. Okay, polynomial and a proper fraction. Example 4, by using long division, show that this one equal to that. Okay, hence express this one as a partial fraction. Okay, now x squared minus 2x plus with 0. So x squared divided by x squared equal to 1. 1 times x squared equal to x squared. 1 times 5x equal to 5x. 1 times 6 equal to 6. Okay, minus here, x squared minus x squared, 0. Negative 2x minus 5x, negative 7x. 0 minus 6 equal to negative 6. So, let's see. 1 minus 7x plus 6. There you go. Okay. So then, what's the equation just now then? X squared minus 2x. Okay. So then, x squared minus 2x divided by x squared plus 5x plus 6 equal to 1 here, and minus whole of 7x plus 6 divided by x squared plus 5x plus 6. Okay, this is the fraction that we are going to come up with the partial fraction. So then, okay, 7x plus 6 divided by x squared plus 5x plus 6 equal to a divided by x plus 2 and b x plus 3. Okay, so I'm going to use a different ink color ink here. Okay, so now let's compare. Okay, let's compare the denominator of this, which actually this is a 7x plus 6 divided by x plus 2 and x plus 3. Okay, x plus 2 and x plus 3, so x plus 2 it will go multiply with x plus 3 here and also x plus 3. And what about this one here now? Yes, we only have x plus 3 and we need another of x plus 2. So multiply with x plus 2 and also x plus 2. Okay, so the denominator for both fractions are equal with the equations here. So now we may compare the numerator. We compare the numerator here now. 7x plus 6 equal to a multiplied with an x. Ax. A multiplied with 3. 3a plus with b times x. Bx and b times 2. 2b. Okay. So the coefficient of x squared, x here, x and also x, where a plus b times x plus with 3a plus 2b. So let's compare now the coefficient of x, which is a plus b, with 7. A plus b equal to 7. And the constant of 3a plus 2b equal to 6. Equation 2. Okay, two equations with two variables, so we use the simultaneous equation. I think that you know how we're going to handle this. Okay, for this one, let's say if from equation 1, I make this one as an a equal to, comparing this a equal to 7 minus b. Equation 3. So equation 3, substitute into an equation 2. So we got a and also a here. 3a, where a is 7 minus b. Then plus with 2b equal to 6. 3 times 7, 21. 3 times b, negative 3b, plus 2b equal to 6. Negative 3b plus 2b, negative b equal to 21. Bring up here, become negative. So negative 21 plus 6, or 6 minus 21, negative 15. And b equal to 15. Okay. And then, when b equal to 15, substitute into equation 3 here, then a equal to 7 minus 15. Then a equal to negative 8. Okay, class. Right now, the equation of this. So, 7x plus 6 divided by x squared plus 5x plus 6 equal to a is negative 8. Negative 8 divided by x plus 2 and b is 15 plus with 15 x plus 3. That's it. Okay, guys. Okay, look at this one here now. X to the power of 4 and x plus 1 multiplied with x squared plus 1. That's right. 2x to the power of 4 divided by x times x equal to x cubed. X times x equal x times 1 equal to 1. 1 times x cubed plus x squared plus x plus 1. Okay. The degree of x from numerator is greater than the degree of x from denominator. This is improper fraction. So we cannot simply come out with a process of partial fraction unless if we form into a proper fraction by using long division. So 2x to the power of 4 plus 0x cubed plus 0x squared plus 0x plus 0, okay, and divide by x cubed plus x squared plus x plus 1. So then, what about this one here now? 2x power of 4 divided by x cubed equal to 2x. Again, 2x multiplied with x cubed, 2x to the power of 4, 2x times x squared plus 2x cubed, 2x times x plus 2x squared, and 2x times 1 equal to 2x. Okay, minus here, 2x power 4 minus 2 power 4, 0. 0x cubed minus 2x cubed minus 2x cubed. 0x squared minus 2x squared minus 2x squared and minus 2x plus with 0. So now negative 2x cubed. Negative 2x cubed divided by x cubed minus 2. So negative 2 times x cubed, negative 2x cubed. Negative 2 times x squared minus 2x squared. Negative 2 times x minus 2x. Negative 2 times 1 minus 2. Okay, so again minus here equal to 0. Negative times negative become positive, so negative 2x squared plus 2x squared 0. Negative 2x, negative become positive, so negative 2x plus 2x 0. Negative times negative become positive, so 0 plus 2 equal to 2. Okay, so now, okay, from here, we come up with 2x to the power of 4 divided by x plus 1 and x squared plus 1 equal to 2x minus 2. Okay, this is in here. Look at this one here now. 2x minus 2 and plus with 2 divided by, okay, look at the remainder here, which is 2. Okay, so 2 divided by x plus 1 and x squared plus 1. Okay, so now this is the fraction that we're going to come up with a process of partial fraction. So 2 divided by x plus 1 and x squared plus 1 equal to a divided by x plus 1 plus with bx plus c divided by x squared plus 1. Okay, this is the quadratic that cannot be factorized. So we're going to leave it something like this. Okay, now as usual, I'm going to change the color of the ink here. Okay, and also here. Okay, right now, look at this. The denominator, it has x plus 1 and x squared plus 1. So for this, it has x squared plus 1. It needs another of x squared plus 1 and also x squared plus 1. And for this, it has already have x squared plus 1. It needs another of x plus 1. So x plus 1 and also x plus 1. Okay. So look at this one here now. The denominator for each of the fraction are now equal. We have already we got successfully equalized the denominator of both of the fraction of this, and we compare with the questions here. So now we are going to compare the numerator, which is 2, okay, something like that. 2 equal to a times x squared equal to ax squared plus with a times 1 equal to a plus with bx times x equal to bx squared, bx times 1 equal to bx, c times x equal to cx, and c times 1 equal to c. Okay, now class, okay, the coefficient of x squared and x squared, a plus b multiplied with x squared. The coefficient of x come out with b plus c multiplied with an x plus with the constant of a and c, a plus c. Okay, now look at this one here. It's already only have 2, but we have x squared and also x. Means that we are going to add up here 0x squared plus 0x plus 2. So we're going to compare the coefficient of x squared, a plus b, with a 0 here. A plus b equal to 0. B plus c also equal to 0. And a plus c equal to 2. Okay, now again I'm going to come up with a equal to negative b, a equal to negative b, equation 1, equation 2, and equation 3. Substitute equation 1 into an equation 3. Okay, a equal to negative b, and we get a here, so it means that it is a negative b plus c equal to 2, equation 4. Okay, now let's make this one here equation 2 with equation 4, c with c, so equation 2 minus equation 4, then we got b plus c equal to 0, and negative b plus c equal to 2. Okay, 2 minus 4, negative here. C minus c equal to 0. 0 minus 2, negative 2. And negative times negative become positive, so b plus b equal to b. So then b equal to negative 1. So when b equal to negative 1, now let's take a look at this one here. A equal to negative b, and b is negative 1. So then a equal to 1. And b negative 1, we compare this with equation 4. So negative b, where b is negative 1, plus c equal to 2. Negative times negative become positive, so then c equal to 1. Here bring to this side become negative, so 2 minus 1 equal to 1. Okay, so now simplify this. 2x to the power of 4. Okay, we got 2x minus 2 plus with a equal to 1. Okay, just now a divided by x plus 1, where a equal to 1 divided by, okay, sorry, here this is x plus 1 and x squared plus 1 equal to x plus 1 and plus with what's below of b? B is negative 1 and c equal to 1. B negative 1, c equal to 1. Okay, so then bx plus c. Bx plus c. So then negative x plus 1 divided by x squared plus 1. B negative and c equal to 1. Okay, so that's it. Okay, now class, the conclusion with a case of partial fraction, improper fraction. Then we need to come up with, use a long division, then we come up with a proper fraction, then we begin the process of partial fraction. Okay, so these all the exercise that you may try yourself, and the final answer for each of the exercise, and these are all the final answers for exercise 2. No, okay, this one here, the question and the final answer, questions and the final answer given then, and the question expressed in partial fraction and the final answer for this. Okay, that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.